Good evening. Daily practice questions standard 8. These questions are equally important for class 7, 6, 8 and 9. 9 also. Right. Question number 1. Write 5 uses of magnets for MRI to lift heavy stones, heavy loads, especially to separate magnetic substances, to separate iron particles from ice in generator dynamos and others, so many others. Question number 2, write 5 properties of magnets. Number 1, directive properties. A magnet shows north south direction. You have to write down. One is direction, attraction and repulsion. One technique to remember. Another, two poles, magnetic field, magnetic field. Direction, it shows north south direction. Like poles repel, unlike poles attract. Another, a magnet attracts magnetic bodies. A magnet has two poles which cannot be separated. Magnetic field, each and every magnet has a magnetic field. Question number 3, distinguish between natural and artificial magnets. You can try yourself. Natural magnets are found in nature, whereas artificial magnets are made by human beings. Another is magnetic and non-magnetic substances. Magnetic and non-magnetic bodies. Matter. Magnetic bodies are attracted towards magnets. Non-magnetic bodies are not attracted towards magnet. And give examples of magnetic bodies: iron, cobalt, nickel, and they are always. Non-magnetic bodies: wood, copper, silver, gold, and so many others. Although they are metals, but they are non-magnetic. Distinguish between them. You can write so many others. Question number 4. Define the following terms. Define the following. A. Magnet, magnetism, magnetic poles, magnetic length, length of a magnet, actual length, total length, magnetic length, the distance between the north pole and the south pole. Define. And another, magnetic induction. See, this is a little bit different. Magnetic induction, I am going to write down the definition of this. It is the process of making a temporary magnet by keeping a magnetic body close to a magnet. When a magnetic body is kept or allowed to touch or being very near to a magnet, the magnetic body becomes a magnet, temporary magnet. This process is magnetic induction. Another is demagnetization. Demagnetization with process. Demagnetization is the process of losing magnetic bodies. For example, hammering, beating, dropping frequently, touching light poles, passing alternating current, rough handling, etc. These processes are the activities which cause demagnetization. In the same way, you can write so many definitions. Lodestone. Lodestone is the first natural magnet found in Asia Minor by the Chinese or Greek Navy, and it is used to show the direction. So, one use of magnet is also to show the direction to lift heavy loads. Lodestone, first natural magnet, and it is not magic box. Remember, define the following item. And another is magnetic field. Magnetic field. This or the field, magnetic field is the area around a magnet where magnetism can be felt. यसको वरिपरि जहाँसम्म म्याग्नेटिक फिल्ड हुन्छ, म्याग्नेटिजम फिल हुन्छ, त्यो चाहिँ म्याग्नेटिक फिल्ड भयो. It is the area around a magnet up to which we can feel the magnetism. Another word is terrestrial magnetism. Electromagnet. The magnet made with bypassing direct current. Terrestrial magnetism. Terrestrial magnetism. This word is a little bit different to you. Terrestrial magnetism is the property of the earth as a powerful magnet. Reason: there is a continuous flow of electricity inside the earth's crust. So the earth also behaves as a powerful magnet, and this is called terrestrial magnetism. Question number 4. Question number 5. How can you conserve magnetic strength? How can you conserve magnetic strength? Just opposite of demagnetization. We can conserve magnetic strength by the following ways: by not passing alternating current, by not touching light poles, by keeping magnetic keepers, by proper handling of the magnets, etc. What are the causes of demagnetization? You just remove those causes and you can solve the problem. जेले गर्दा demagnetization हुन्छ त्यो नगर्ने अनि मात्रै त्यो magnetic force conserve हुन्छ. Question number 6. State scientific reasons. A number: repulsion is a sure test of magnets. Why? Attraction is also test, but it is not 100% sure test. Repulsion is a sure test of magnets. First of all, you have to write down like poles repel. Like poles of a magnet repel, don't attract each other. But unlike poles attract. So, since unlike poles attract, we can easily find out which is a magnet and which is not a magnetic, which is magnet, which is a magnetic body. These two bars look alike, same color, same length, same breadth, but one is iron rod, another is magnet. How to know? can't see such regular patterns and irregular patterns. But how to know? There is no attraction in the middle of a bar magnet, but there is attraction everywhere in a magnetic body. Magnetic body को सबै ठाउँमा attraction हुन्छ, तर magnet को बीचमा attraction हुँदैन, छेउछेउमा maximum attraction हुन्छ. There is maximum magnetic force at the poles of a bar magnet, but there is no attraction in the middle, but there is attraction everywhere in a magnetic substance. So repulsion is a sure test. Another, keepers are used while storing magnets. Why? Keepers are used while storing magnets. Why? The answer is keepers are used while storing magnets not to lose or to avoid demagnetization. To avoid demagnetization. Keepers don't cause demagnetization. And the magnetic force remains for a long time. Magnetic keepers preserve magnetic strength for long time. When we use keepers, magnetic strength is kept for long time, and there is no demagnetization or to decrease demagnetization. So just write down. So they are used while keeping or storing magnets. Another is an electromagnet is more useful than an ordinary one. You can write down the answer yourself. An ordinary magnet, the poles cannot be changed, but an electromagnet, the poles can be changed. We can increase or decrease the power or magnetic strength, and it is more powerful but temporary. The earth behaves as a powerful magnet. Why? The earth behaves as a powerful magnet. How to know the answer? Can you say the earth is a magnet? Yes. There is a continuous flow of electrons. There is a continuous flow of electrons inside the Earth's crust. If there is continuous flow of electrons, magnetic field is created. Due to the electrons, flow of electrons, magnetic field is created, and the earth behaves as a powerful magnet. This is called terrestrial magnetism. This is called terrestrial magnetism. Why? The earth behaves as a powerful magnet due to the continuous flow of electrons and due to the magnetic field created by the electrons. In the same way, another question: heating causes demagnetization. Why? Heating causes demagnetization. How? When any magnet is heated, the molecular magnets, the regular patterns become irregular. On heating a magnet, what happens? The open chains, the open chains become closed chains. The open chains become closed chains. That means the regular patterns become irregular, which attract each other. As a result, the magnet demagnetizes. The magnet loses its magnetic properties because the regular patterns become irregular, open and closed. Question number 5. State. Question number 5 is you can write some others differences between write examples, or you can write examples of a magnetic and non-magnetic bodies. Write examples of magnetic and non-magnetic bodies. See, examples of magnetic bodies: iron, cobalt and nickel, or their alloys are magnetic bodies because they are attracted towards magnet. Non-magnetic bodies, non-magnetic substances or bodies are not attracted, like wood, copper, silver, gold. Although they are metals, but they are not magnetic. They are not attracted towards magnet. Aluminum, but sometimes aluminum can also be attracted by mixing with iron, nickel or cobalt, by making alloys. Wood, copper, silver, gold, zinc, plastic, etc. are non-magnetic bodies. Magnetic bodies and non-magnetic bodies. Another lodestone or natural magnet. One example of natural magnet is lodestone. Its name is also leading stone. The molecular formula is Fe3O4, triferric tetroxide or magnetite. This is a natural magnet. Lodestone or leading stone, natural magnet. In the same way, artificial magnets. Example: artificial magnets. Man-made magnet. Example: bar magnet, round magnet, horseshoe magnet, cylindrical magnet, cylindrical or spherical magnet. Another is electromagnet. Electromagnet. There are some examples of artificial magnets which can be made in the lab by human beings. Bar magnet, round magnet, horseshoe magnet, cylindrical magnet, spherical magnet, electromagnet. They are some examples of artificial magnets. Question number 5. Question number 6. Magnetic theory. Question number 6 is draw diagrams to distinguish between magnetic and non-magnetic bodies. How to know magnetic bodies and non-magnetic bodies? Diagram. See. North Pole, South Pole. Magnet. It is a magnet. Why? They are open chains. They are. It has open chains or regular pattern. All the North Pole show one direction and all the South Pole show another direction. Open chains are regular patterns. Regular patterns of molecular domains or magnetic domains or molecular magnets. Another is what is this? This is a magnetic body. Magnetic body. Why? Because it has closed chains to form ring light which attract each other and there is no magnetism. If any substance has open chains or regular patterns of molecules, it is a magnet because it has attraction power. If it has closed chains or irregular patterns of molecules, randomly placed molecules, all the molecular magnets attract each other and there is no magnetism. So it is a magnetic body. That is the difference between magnet and magnetic body. Question number 6. Question number 7. Question number 7. State Weber-Ewing molecular theory of magnetism in 4 points. There are 4 points to state Weber-Ewing molecular theory of magnetism. नेपालीमा के भन्न खोजेको भन्दा वेबर र इविङ भन्ने दुईटा साइन्टिस्टहरूले यो पत्ता लगाएका हुन् मोलिकुलर थ्योरी अफ म्याग्नेटिजम भनेको म्याग्नेट चाहिँ मोलिकुलर म्याग्नेट्सबाट बन्छ. One magnet can be broken into 2, 2 to 4, 4 to 8, 8 to 16 and so many possible, smallest possible magnets can be split from a big magnet. Each and every magnet has all magnetic properties. The solution is as follows. The molecular theory of magnetism is as follows. Point number one. What is the molecular theory of magnetism? Every magnet is made up of only magnetic materials like iron, cobalt, nickel, or their alloys. The alloys of iron, nickel, cobalt, or these three metals, only three metals, iron, cobalt, and nickel. But some you can write steel also, but steel is also a type of iron. Every magnet is made up of only magnetic materials. That means we cannot make magnets from non-magnetic bodies. Magnetic body material बाट मात्र magnet बन्छ. We can make magnets from magnetic materials. Each magnet has two inseparable poles. Each magnet has two inseparable poles, and each magnet can be split. If you forgot the word split, you can write broken into magnetic molecules. Magnetic molecules are molecular magnets, or they are also called magnetic domains. For example, this is one magnet, north pole, south pole. You can break into two, north south, north south. Again, you can break into two, north south, north south, north south, north south. You can break one magnet into two, having north and south poles. Two magnets into four, four into eight, eight into 16. In this way, you can break a very big magnet into infinite numbers of smallest possible magnets. Those smallest possible magnets are called magnetic molecules or magnetic domains or molecular magnets. एउटा ठुलो चुम्बकलाई सानो सानो टुक्रामा सकिन्छ. It means a big magnet is the combination of magnetic domains. सानो सानो मिलेर ठुलो बन्छ, ठुलोलाई टुक्राउन सकिन्छ. A big magnet is broken into many pieces, and many or infinite numbers of molecular magnets combine together to form a big magnet. Point number one, only magnetic materials. Point number two, each magnet has two poles, and each magnet can be broken into infinite numbers of molecular magnets. Point number two. Point number three. Point number three is difference between magnetic bodies and non-magnetic bodies. When a magnetic body is not magnetized, means in the unmagnetized form, what happens when a magnetic body like iron, steel, nickel, cobalt, or alloys is not magnetized? What happens? What is there? Close chains. When a magnetic body is not magnetized, there close chains or ring line, close chains or rings attract each other and and there is no magnetism. There is no magnetism or no magnetic force in a magnetic body because there are irregular patterns of molecules. The molecules are randomly placed, close chains or randomly placed, and those close chains molecules or molecular magnets attract each other and there is no magnetic force. एक आपसमा तानेर त्यसमा magnetic force equal and opposite हुन्छ. Total magnetic field is 0. For example, I will show here. This is called closed chains. Closed chains or random molecules. Random molecules or closed chains face in any direction, they attract each other and there is no magnetic force. The magnetic force, there is magnetic force, but the forces are equal and opposite, and finally the net resultant force. The net force is 0 due to equal and opposite force. Another, just like it is a magnetic body, it is a magnetic body. A magnetic body has closed chains or random molecules which attract each other and there is no magnetism. Number 4 and last, when a magnetic body is not magnetized, when it is not magnetized, closed chains are there. When a magnetic body is magnetized, when it is the same substance is magnetized, what happens? The closed chains are random molecules. Closed chain means random molecules. The molecules which face in all directions, roughly randomly placed molecules, the closed chains become open chains. Open chains means regularly placed or arranged. Regularly placed or regularly arranged molecules. When a magnetic body is magnetized, the closed chains or random molecules become open chains or regularly arranged molecules. Closed chains become open chains. So there is magnetism. There is magnetic force. Why? Because the poles are free to attract. Poles are free to attract. See. North pole and south pole. What is this? This is a magnet. How do you know it is a magnet? Because all the molecules are now changed into open chains. Open chain means regular molecules. Now these molecules are free to attract and there is magnetic force. So there is magnetism. Point number one is a magnet can be made from magnetic body. Point number 2, each and every magnet has 2 poles which cannot be separated. And a magnet can be broken into many smaller magnets. called magnetic domain. Point number 3, when a magnetic body is not magnetized, closed chains are formed. Means the molecules are random and there is no magnetic force because they attract each other. IV, when a magnetic body is magnetized, when the same substance is magnetized, what happens? The irregular molecules become regular. See, irregular molecules become regular means the closed chains become open chains. Now they are free to attract. So that is the difference between point number 3. Point number 3 is magnetic body has closed chains, there is no magnetism because they attract each other and the total magnetic field is 0. IV number, when the same magnetic body is magnetized, यसलाई म्याग्नेटाइज गर्ने भनेको क्लोजलाई ओपन बनाउने भनेको. To magnetize a magnetic material means to change closed chains, to turn closed chains into open chains. Now the open chains are free to attract, so there is magnetism. Now it is able to attract magnetic bodies like iron, steel, nickel, cobalt, or their alloys. This was for today.